In this video, we will learn how to create classification models using various machine learning algorithms with Python, and we'll be using the iris data. In iris data, we have three groups, 0, 1, and 2, and we have four independent variables, and we have 150 rows of data. So classification is a very common and very useful task for decision making. And there are some machine learning algorithms used for creating classification models. Some of the common machine learning algorithms are decision trees, neural networks, and logistic regression. In tertiary classification, we classify entities into three groups, 0, 1, or 2. We have a data file called irisdata012.csv. A subset of this data is shown here. There are four independent variables, sepal length, sepal width, petal length, and petal width. And then we have a class variable, which is a group variable with three groups, 0, 1, and 2. So here we see 6 rows of data. In the actual data file, there are 150 rows of data, 50 for class 0, 50 for class 1, and 50 for class 2. And manually, we can see that the petal lengths are the smallest for group 0, medium for group 1, and longest for group 2. Similarly, petal widths are smallest for group 0, medium for group 1, and widest for group 2. There's no significant difference in sepal width. There is some difference here. Class 0 sepal length is smaller than classes 1 and 2. So let's see if our machine learning algorithms can find some patterns. So we can use Python to build tertiary classification models using decision tree algorithms, neural networks algorithms, and logistic regression algorithm. We can also create confusion matrices for the classification models. So there's a library called sklearn, and there's a website for it. There are modules called tree, neural network, linear model that can be used to build machine learning algorithms. And there's some functions, decision tree classifier, MLP classifier, logistic regression, and so on. So we will now switch to Spider, where we will see how to write code to create various classification models, tertiary classification models, using the data in irisdata012.csv. You should now see Spider, and you can see the iris data here. By the way, if you have not watched the video in which we are doing classification on very simple data file 1 and very simple data file 2, please watch those first and then proceed with this, because we'll be using the code we created in the previous videos. Okay, so we have sepal length, sepal width, petal length, petal width, and class. Those are my variables. First four are independent variables, and the last variable is my dependent variable, or the group variable. I have 50 rows of data with class 0, and then 50 rows of data with class 1, and then 50 rows of data with class 2. So total 150 rows of data. So here we will write some code to read the data file and then create classification models using decision trees, neural networks, and logistic regression. So here's the code to read the data file in a data frame called df_iris, and then we extract the x variable for independent variables using the columns for sepal length, sepal width, petal length, and petal width, and we extract the class column as a y variable, and then we reshape the x variable as a numpy array with -1 and 4, because we have 4 independent variables. So if we run this code and we look at the data frame for iris, we can see that it read 150 rows of data, and the x array has 4 columns, 0, 1, 2, 3, and 150 rows of data. The first row is labeled 0, and y has 150 rows. Okay, so now we can just copy and paste the code we had written for very simple data file 1, because the only difference is the data file, the process is the same. So I'm going to copy and paste the code for creating the decision tree classifier, neural network classifier, and logistic regression classifier. So if you run this now, there. So first, let's look at the decision tree classifier. First of all, there's a plot. Here's a decision tree for classifying each row as either 0, 1, or 2. Let's look at the output. So the actual class and predicted class using the decision tree classifier. You see all the zeros are predicted as zeros. The ones are predicted as ones, and twos are predicted as twos. We don't see any errors. So the confusion matrix is 100% accuracy. 50, 50, 50 on the diagonal means 100% accuracy. All 50 of group 0 were predicted as 0, all 50 of group 1 were predicted as group 1, and all 50 of group 2 were predicted as group 2. How about neural network classifier? Let's see how that did. So all the zeros were fine. How about the ones? Oh, I see this one was misclassified as 2, and this one was also misclassified as 2, and this one was also misclassified as 2. Okay, how about twos? This 2 was misclassified as 1. So the confusion matrix for the neural networks classifier, the 3 of the ones was misclassified as 2, and 1 of the twos was misclassified as a 1. So that's the confusion matrix. And then how did the logistic regression classifier do? All the zeros were fine. Oh, I see one misclassification here. This one is misclassified as 2, another one misclassified as 2, and another misclassification 1 as 2. So 3 mistakes there. How about twos? I have one misclassification here. 2 is misclassified as 1. Okay, so this confusion matrix is similar to the confusion matrix for neural networks. So that's the end of this lesson.